Hello again, everybody. Today we're going to be talking about how we can go about running an independent samples t-test in SPSS. You can see that we've got the 2014 subset of the General Social Survey open in SPSS. Again, this is intended to be a reflection of the full data. It's about half a dozen variables that we can take a look at for some of our examples. Remember, I'm not counting year in here. Since year doesn't vary, we wouldn't consider it a variable. Now, you might remember that when we run an independent samples t-test, we're talking about a bivariate analysis. Our independent and our dependent variable and the relationship between them. Ultimately, the comparison of the means between the two categories of the independent variable. So our independent variable is categorical and can only have two responses for us to look at. Now, to be clear, in SPSS, the variable can have any number of categorical responses, but we can only look at two of them, and we'll identify and tell the program exactly which two we're going to examine. So you can see we've got variables like race and sex, where we've got 2 or 3 categories. Now, the only continuous variable we have here, and as you may recall, a t-test requires that our dependent variable be continuous and normally distributed. But the only continuous variable we have here is the variable of age. So for the purpose of our examples today, it's going to have to be age as our dependent variable. And we will look at both the variable of sex as well as race just to sort of demonstrate how we might go about identifying those categories. Now, the first thing we're going to look at is we're going to make sure we understand what the categories are for the variable of interest. So in this case, let's say we want to start off by talking about the variable of sex. If we come over to the values, we can see that there are actually only 2. And they are coded 1 and 2. 1 for male, 2 for female. When we look at race, you can see we actually have 3 values. 1, 2, and 3. White, black, and other. Now there's also the variable of 0. But as we've talked about before, you can see over here that 0 is considered a missing value, which means any cases where race is coded as having a value of 0 is getting dropped from the analysis. So let's start off by taking a look at how we go about identifying in SPSS which variables are going to get compared for this t-test. I'm going to go up to Analyze, and I said to you before that ultimately what we're talking about here is a bivariate analysis. More specifically, it's the comparison of means between 2 groups, and those 2 groups are going to be identified with the independent variable, while the continuous variable that we're calculating the means for will be with the dependent variable. So if we go down our list and analyze, you're going to see about 5 down, there's actually a section called Compare Means. And if we scroll over here to the right, you can see right there, third option down. And by the way, if you're using a slightly different version of SPSS, this might look a little bit different, but it will still be under Compare Means. But you'll see Independent Samples t-test. So let's click on that. Now, here you can see, I'm going to drag this out so we can look at the variable names in total. You can see here on the left-hand side, we have all of the variables in our data file. On the right-hand side are our test variables. Now, test variables is going to be a reflection of our dependent variable. So our numeric, our continuous variable here, our variable measured at that interval or ratio level is going to be over here under test variables. And then below it, the grouping variable is going to be where we'll put our independent variable, which will have 2 categories associated. So for this first example, we're going to use the variable of sex, which again, we said 1 was male, 2 was female. So I'm going to take the variable of age, and I'm going to move that over here to test variables. Now the variable of sex, I'm going to move over here to the grouping variable. Now you have to remember that the program is going to give you an option here of telling it which groups to compare. So you can't simply click OK. In fact, you notice that OK is grayed out. You actually don't have the option of selecting it. So you actually need to go down here to define groups. And what it's looking for here are the numeric values associated with the categories in the variable, that independent variable of interest. So again, for sex, we said 1 was male and 2 was female. So I'm going to go in here, I'm going to say group 1 is identified as 1, group 2 is identified as 2. Now, by the way, I could do this the other way around. I could say group 1 is equal to 2, or group 2 is equal to 1. It doesn't really matter, as long as we're telling the program to separate the groups out this way. Now, the reason it does matter a little bit is because we want to make sure that when we look at the output, we're very clear about which group is which. But once this is identified for both group 1 and group 2, we're going to say continue. And now you can see on the bottom left-hand side that the OK button has been opened back up. The grayed out is gone. And I'm going to say OK. Now, the breakdown here is actually really straightforward. So let's go through this very quickly. You can see that it starts off at the top with the group statistics. This is a simple breakdown of information about the two separate groups. So for example, here you can see that we've got about 890 men versus about 1,151 women. The average age difference between them is very small. It's really about 0.3 of a year, so about a third of a year total. So that suggests right away we might not be talking about a statistically significant difference. We can see the standard deviations are being reported as well as the standard error of the means. Now, when we get to the second row, which includes our hypothesis test, we have to be very careful here because it's very easy for us to look at the wrong portion of the output. If you take a look right under here where it says independent samples t-test, on one side over here you see it says Levene's test for the equality of variances. And notice how this bar here goes all the way up. This is telling you that we are separating out two different things. So on the left-hand side, we have Levene's test for the equality of variances. On the right-hand side, we have the t-test for the equality of the means. These are two separate tests. Now, we need to look at the one on the left first. And the reason we have to do that is the program is trying to determine whether or not there needs to be a correction for the fact that the variances or the standard deviations of the two groups are too markedly different from one another. And you can see here that's exactly what this test is doing. It's doing it as an F test, and we'll talk more about that later on with the F distribution, which is associated with an ANOVA. And you can see here that we have an F value of 7.695. I don't have the distribution table in front of me, and I very much doubt you do either. But the important thing is looking at this, we can see that the sig value is 0.006. So ultimately, these two first columns are a hypothesis test. The null hypothesis is that the quality of the variances is the same. In other words, what we see over here, equal variances are assumed. The research hypothesis is ultimately that they're not. So when we look at this, we see ultimately that we are going to reject the null hypothesis, that in fact the variances are different from one another. And what that means is we want to use the second row when it comes time to look over here at the t-test for the equality of the means. Now, here it doesn't make a huge difference, but the truth of the matter is when we get to some small samples, this can actually have a pretty large impact, and we have to be real careful knowing which of these rows to use. So again, if my sig is below 0.05, I'm going to use the bottom row. If it's above 0.05, I'm going to use the top row. Now, coming over here, I can now ignore everything on the left-hand side so I can address that t-test for the equality of the means. This first column here gives me the t-test statistic. You can see right away it's pretty small. It's only about -0.4. With the degrees of freedom here that we have, we would know that right away it's a large number based on what we've looked at with our t distribution before. We're looking for a value to exceed either 1.96 or -1.96 to reject a two-tailed hypothesis test, and we're not even close to that. So we know right away that our associated sig value is going to be well above that 0.05 cutoff. And sure enough, you can see here it is. So our t-test, and again, we should be using the bottom row, so I misspoke before, but it would be -4.24. Our degrees of freedom are about 1964, and our sig value is well above that 0.05 cutoff, ultimately suggesting to us that we failed to reject the null hypothesis, that even though we've got this difference in the variances, that difference in years, which again was very small, and in fact you can see it being reported out here, -0.3. So less than a third of a year difference between the two groups. We're probably not surprised that there is no statistically significant difference between these two groups. All right. Very quickly, I want to just make one other demonstration and then we can wrap this up. Now, we said before that with sex this was easy because there were only two groups anyway. If you recall, however, with race of respondent, we said we have white, black, and other. Now, if I want to compare groups 1 and 2, I could pretty much leave things the way they were set up before. So if I go to Analyze, Compare Means, and Independent Samples t-test, if I take age out and I put race in, having left the grouping variable in this case, I have to make sure that it's going to match up with what I'm talking about. I apologize, I did that backwards. So, I'm sorry, race should go down here, and then we would have left age up here, in other words, to be our test variable. Now, with race, we know we had three values, white, black, and other, 1, 2, and 3. Now, if I set this up with 1 and 2, which the program has remembered from my prior example because I didn't reset it, right now it's going to do a comparison of the white and the black respondents, and that's it. If, however, I went in here and I switched this to 2 and 3, then it's actually telling the program to compare the black respondents, which you may recall were reflected with a value of 2, and the other respondents, which you may recall were reflected with a value of 3. Or for that matter, I could switch it so that now group 1 is going to be the white respondents and group 2 is going to be the other respondents. And if I say continue here, and then OK, you can even see this being reflected up here in the responses. It gives you the breakdown of 1, which was white, and 3, which was other. And once again, as we look down here, we can say, well, there's actually a pretty big difference here, right? You've got almost the average age for the white respondents was 50, and the average age for the other respondents was 40. We come down here and we can see that the Levene's test for the equality of variances is not significant, so equal variances are assumed. And we scroll over here on the right, and we can see, sure enough, that my sig value is listed as 0.000, well above that 1.96 that we would normally use associated with a 0.05 alpha. Now, as a reminder, 0.000 is never really the value. And if I were to click in here, let me smooth this over a little bit, and put my cursor over it, you can see the value is actually 2.65 to the e to the negative 11th. In other words, if I move my decimal point 11 spaces over to the left, then that will give me the actual sig value. All right, so these were just a couple of very simple examples using a independent samples t-test. I apologize for my blunder partway through. I hope, as always, if you have any questions, you will let me know. Have a very great day.